we talk about two more things. We talk about the greatest common factor, which is the GCF. Now, what it is that is the largest number that is a factor between selected numbers. The biggest number, or it's, in other words, it's the biggest number that goes into all selected numbers. Now, just so you know, this is actually a small number, whereas the LCM, or the lowest common multiple, is the smallest number that is a multiple between selected numbers. The smallest number that all selected numbers go evenly into. And this one is actually a large number. And where it comes into what a small number and large number are is talking about what a factor is and what a multiple is. A factor is something that makes up another. For example, if we talk about in our section 1, we talked about writing down the prime factorization. We're going to bring that back. You're going to bring back the prime factorization. So we're going to look at the small numbers that make up 245, 315, and 770. Same time, for the lowest common multiple, we're looking for a number that all of these numbers would actually be going into. So they are multiples of these smaller numbers. So if I look at 245, I know for a fact I can break down 245 by 5, and I have 49. Now 49 is 7 and 7. So meaning 245 is 5 times 7 times 7. Yes, we could write 5 times 7 squared. This is going to come into a lot better practicality sake for our next two examples. 315. Well, I also know that that can be broken down by 5. 315 divided by 5 is 63. 63 can be broken down. Let's see, it's a 6 add 3 is 9, which means I know that it can be divisible by 9. 63 divided by 9 is 7. Now 9 is 2 3s. So 315 is 3 times 3 times 5 times 7. And 770 can be broken down into 10 and 77. 10 being broken down into a 2 and a 5, 77 being broken down into a 7 and an 11. So 770 in order will be 2 times 5 times 7 times 11. So all of this comes into a whole bunch of practicality and practical use when we talk about the GCF and the LCM. Again, the GCF is the greatest common factor. It's the largest number that is a factor. So again, it is the largest number that is a factor between selected numbers. So basically, it's looking for what is the biggest number that is in all of our numbers. Well, you may look at this and say, okay, 245 has a 5, a 7, and a 7. 315 has a 3, a 3, a 5, and a 7. 770 has a 2, a 5, and a 7, and an 11. Well, the number that is in all of them, yeah, is 7. Well, that's not exactly how GCF is calculated. It is the biggest number that is in all of them. And the way that I like doing this is by showing it just with setting or lining everything up. I know that some people are able to do it, and at the same time, because of how I set this up, it's a lot easier to see, but I'm going to write down my notes down here. So 770 is a 2, a 5, a 7, and an 11. 11. Say it, but I don't write it. And there is a reason for this. There's a method to my madness. 315 is 3, 3, 5, and a 7. You'll notice what I'm doing here is I'm actually lining up the same numbers together. For example, 245 is a 5, a 7, and a 7. I'm lining up numbers that are the same. Now, I don't like how this looks, so I'm going to fix it. The reason I like lining these up is for the simple fact that I can then determine what is in all three. Well, there's only a 2 in the 770. There's only a 3 in the 315. At the same time, their second 3 is only in the 315. There is a 5 in all three of the numbers. There's also a 7 in all three of the numbers. There is not a second 7 in any other number but the 245. There's no 11 in all of them, which means the greatest common factor is actually going to be 5 times 7, which is 35. The way that I can do that, or go farther into that, is I can take 245, divide by 35, and I get what? 245 divided by 35, I get 7. Oh, look, that's the number that's left. If I take 315 and divide it by 35, because it is a factor, I'm going to be left with 9. And that's what I type into my calculator, and I get 9. I get 770, 70, that looks like a 0. And I divide it by 35. I get 22, which is what 2 times 11 is. So we can find out exactly what remainders are when we have our greatest common factor. So again, just tie again to what the definition is. It is the largest number that is a factor between selected numbers. Now, note when we were looking at it, we were thinking, okay, maybe the number is just 7. No, it is what's common between all of our numbers. There's a 5 common in all of them, and there's a 7 common in all of them. If I go to my next example, 180, let's see. I'm just, well, actually, yeah, I might as well do all my factor tree work. 180, see, that's going to be 20 and 9. 20 is 4 and 5. 9 is 3 and 3. 4 is therefore 2 and 2. Just do a double check. Yep, I'm good. And then if I look at 224, well, 224, let's see, I know it's even, so I could just do 2. And I divide 224 by 2, I should get 112. So I know I can't, it's not divisible by 5, it's not divisible by 3, because 1 plus 1 plus 2 is 4. Well, I'm going to have to go at least another 2 just to figure things out. 56. And 56 is actually one of my favorite numbers, so I know that that's going to be 7 times 8. And 8 is 3 2s. So if I do my work, I have 2 2s in my 180. Now I'm going to be leaving space because I can also see that I have 5 2s in my 204 or 224. So I leave enough room for 3 more 2s, and then I can write my 3, 3, and 5. My 224 is 5 2s. 3, 4, 5, and a 7. When I find out what my greatest common factor is, I can see that there's no 5 in any of them. There's no 3 in them. There's no other 3. There's no 7. I only look for what is common. And in this case, there's only 2 2s that are common. My greatest common factor will then be 2 times 2, which is 4. And I can obviously check my answer. 180 divided by 4 should work out as 45. 224 divided by 4 is 56. And there we go. So they are factors. At the same time, there's not going to be anything common between 45 and 56. I want to double check that one more time. 45 is 3 times 3 times 5. 56 is 2 times 2 times 2 times 7. There's literally nothing else in common. Same time, these 2 3s and a 5 is what's left here. These 3 2s and a 7 are what's left in here. There's nothing else common in here. There's no common factors. Factors are the smaller numbers that make up your composites. So just give me a second. And when we go over to our next page, we're going to talk about our lowest common multiple. So again, just going to go back to the definition. Lowest common multiple is the smallest number that is a multiple between selected numbers. Now, the biggest thing behind multiple is it's like it's skip counting. Multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Skip counting by 2, 2, 4, 6, 8. Well, those are 2, 4, 6, and 8 are all multiples of those smaller original numbers, 2, 3. If I look for the multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40. Those are all the multiples. So if I want to look for the lowest common multiple of these numbers, now I've already done the prime factorization of it. I'm just copying and pasting from the other page. The lowest common multiple is looking for basically the skip counting of 245, 315, and 770. Instead of us doing, okay, 245, then 490, then 735, so on and so forth, trying to figure out what is the lowest number that all of these go into, there's a quicker way. And it also comes into effect of how I have this set up. Of course, oh, sorry, there should be another 5 here. It's not copyright. There is a 5 common in all of them. There is a 7 common in all of them. Well, I'm going to write my 5, I'm going to write my 7, and here's how I do the rest. I just look for, again, is there anything else common? Well, there is 1, 2 in here, but there's no other 2s in these. So I'm just going to circle my group of 2s. There's only the 2 in the 770. I'm going to circle my 3, which is only in the 315, but it's not in the 245 or the 770. I'm going to circle this other 3. And it works. I'm going to circle this 7. And I'm going to circle this 11. Now you'll notice in all of this that even though there is a repeat of these 3s, and there's even a repeat of these 7s, each one does get circled, but I look for what is common between all of them first. So for example, there's 3 5s in here. So I'm going to circle 1 5 from all of them. There's 3 7s. Well, there's only one remaining 7 in this 245. Well, I'm going to have to circle that 1, 7. I'm going to circle this 1, 11. Circle this 1, 3. This other 3. And that 2. If I take my 2, 5, 3, by the 3, by the 5, by the 7, by the 7, by 11, I should get 48,510, which means that if I skip counted by 245 all the way up, I'd see that it would go to 48,510. Same thing, skip counted by 315, skip counted by 770. You don't have enough time in your day to waste it skip counting. That's why we can use this method to find out our lowest common multiple. At the same time, I can double check and make sure that this all works out. Is it a multiple? Well, if I divide it by 245, it comes out as a whole number. I can do the same thing. 48,510 divided by 315. I get 154. If I take my 48,510 and divide it by 770, I don't know why I keep on doing that. I get 63. So what that means is I actually have to skip count by 245, 198 times before I'd even get to here. 154 times for 315 and 63 times for the 770. Not the best use of your day. Sorry, just like I like writing my line. Just say it's what this is, this is, this is. So let's look at another one. 15, 32, 44. Well, I'm going to go with my numbers. Now I'm just going to kind of do my factor tree in my head. I know that 44 is 2 times 2 times 11. 32 is 2 times 2 times 2 times 2 times 2. And 15 is 3 times 5. The reason I like this example, because there is no greatest common factor. There is nothing common between all of them. 15 is complete outlier. There's not even anything common between 15 and 32, or 15 and 44. But there is something common between the 32 and 44. So if we're going to find out our lowest common multiple, all we have to do is, again, do our lineup. Even though there is no 2 in there, well, it just means that we're just not going to include a 2 from the 15. But there is that pair between the 32 and the 44. There is a second pair. Do you need to actually do all this circling? Not necessarily. It's just an organizational tool to help make sure that all of my work is in line and in order. Same time, there's no 3 in any of them, so I'm just going to circle my 1, 3. There's no other 5. There's no other 11. But they do need to be included in our lowest common multiple. Multiply it out. 5,280. I can do the same check. 5,280 divided by 15 should come out as 352. I just want to do a double check. $5,280 divided by 32. And the only reason I'm doing all this division just to make sure that they are actual multiples, which means that our dividend comes out as a whole number. sorry, lost my train of thought. 5280 divided by 44. And there we have it. That's our talk about what GCF and LCM are.